So hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Rishabh Kumbhalkar, part of the data science team at Analytics Vidhya, and I'll be the moderator for this session. For those who have joined us for the very first time, a brief introduction about the DataHour sessions. So the DataHour is a series of sessions conducted by Analytics Vidhya, led by the top industry experts. It is a fun way to understand the concepts of data science from leading players in the data tech domain. And as the name suggests, it is 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. Now, on to our session today, which is about creating an effective data science notebook and communication. In this DataHour, Martin will share some tips and best practices for effective data science communication and will cover the aspects of notebooks such as how it can play a powerful role at any step of machine learning and data science workflow, how it allows you to communicate and improve your work from data ingestion to actionable insights, and how it can serve as a reproducible documentation of your work and reduce the technical debt. Also, this DataHour will give recommendations on how to design impactful notebooks according to your needs. Okay, so now on to our speaker. In this session of DataHour, we have Martin Henze from United States with us. Martin has a PhD in astrophysics from Technical University Munich and currently works as a data scientist at Yipit Data. He has extensive experience in data wrangling, EDA, and data visualization in Python and R, and is passionate about storytelling and communication. He is also one of the top members of the Kaggle community as the first ever kernels grandmaster and former #1 in the notebooks ranking with 23 gold medals to his name. His granular level documentation is well lauded within the community. In addition, he is a discussions grandmaster with 108 gold medals. Wow. So with this, over to you, Martin. The virtual stage is all yours.
Thank you. Thank you very much. Thank you for the kind introduction, and good evening to everybody. And for me, it's good morning, but it's good evening for you. So I hope that you'll have fun this evening during this DataHour. And as has been said, I'm Martin. I'm Heads or Tails on Kaggle, and you can find me mostly there and on Twitter as well, on a slight variation of this name, Heads or Tails. And you can follow me there, see my content there, and interact with me there. And I also want this DataHour today to be interactive as well. So I have a bunch of slides here where I kind of talk about some of the underlying concepts and some of my guidelines that I want to share with you. But I also invite you to ask a lot of questions in the chat, for instance, or whichever the best way is to ask questions, so that we can open up a dialogue on the aspects of notebooks and communications that would be valuable for you. And I think that being able to communicate your insights and your process and your findings clearly and in an accessible way is a very underrated but very valuable skill for a data scientist or a machine learning practitioner to have, because in every step of your workflow, you're going to be talking to somebody. You're going to be talking to people who give you data. You're going to be talking to the people who will use your results. You're going to be talking to your colleagues to kind of explain and do some brainstorming and get more ideas. You might even be talking to an audience to try to summarize your findings, and then depending on the audience, you want to focus on different aspects of your work. So communication is really one of the key aspects. And I believe that the communications part and the notebooks part are very strongly related, because the way that we do data science and machine learning nowadays happens a lot in notebooks, and for a good reason, because they are like a flexible and interactive lab book, essentially, that is also reproducible. So you can kind of combine your code, you can combine your documentation, you can combine your ideas for future analysis, And then, when you get back to it half a year later or a year later, everything should be there in a shape or form that allows you to relatively easily pick it up and then pivot it to a new and related project, for instance. Okay, so the first part will be dealing with exploratory notebooks, because this is the part of your analysis where you are communicating with your data, right? So you want to analyze your data, look at it from different points of view, and want to really understand what your data tells you, because a lot, pretty much almost everything depends on the data. And in order to emphasize this, because we all know this, but in order to emphasize this again, let's think about a very simple classification problem, like here, this example from the sklearn docs, where we want to distinguish between the red and the blue points, and we have this little support vector machine here that allows us to draw a line and to draw a divider, and everything is nice, everything can be cleanly separated, which is of course rarely the way, but this is what a model does, right? A model looks at your data and then establishes generalizable rules from your data. So every time you use a model, it's important to keep in mind that models are always a simplified description of your training data, right? That's what we want a model to do. We want a model to look at the data and learn from it, learn the kind of big picture ideas from it and not overfit. But that also means that if your training data is bad in some way, right? If it's biased, if there's a lot of noise in it, then your models will not be good either. So garbage in and garbage out is a very fundamental concept in, in science, in engineering, and in data science and machine learning engineering as well, right? You can't expect to get a great model performance if you don't give it great data to learn from. And one example, so I'm going to use some examples here in those first couple of slides that are not necessarily directly related to machine learning and kind of standard machine learning problems, because I'd like you to think outside the box a little bit and to see where you can encounter these issues in real life. So if we're, from a point of view of somebody who's living in the United States, right? The 2016 election was a pretty big shock in many ways, also because the kind of later President Trump consistently outperformed all the polls that were taken in those key states, which then later led the pollsters to realize that the way that they're polling, their kind of methodology was flawed, was biased, that there was a significant bias towards people not telling them that how they would vote in the election if they would end up voting for Trump instead of Clinton. So everything was kind of shifted in a systematic way. So there are these kind of systematic biases that are different from the statistical noise that you have. And they are very crucial to keep in mind when you are designing a machine learning problem as well, so that you want your data to be representative. And this was not a representative polling, so it couldn't be relied on to predict the election outcome. And this bias can come in many different ways, right? If you're thinking about a computer vision model, for instance, that you want to be able to predict like skin cancer, melanoma, or something like this, then you want to make sure that your model will be able to perform equally well on people with lighter skin, where it might be easier to detect these melanoma, and also on people with darker skin, where it will be more challenging. And you don't want to end up in a situation where your training set is only made up of people with lighter skin, and the model is very good, very confident. And then in production, in the real world, the model would be used on images of people with all kinds of skin color, skin shades, and it ends up being systematically worse for people with darker skin because it hasn't seen those examples in the training, right? So bias is important. And when you think of bias, you also always want to consider the ethical implications of your work. So this is worth emphasizing and including here, because your model is going to be used in real world scenarios. And sometimes these real world scenarios can have an ethical impact depending on whether there might be some bias in your model. So consider this. And this information about ethical impact comes a lot with domain expertise, right? Which is another avenue of communication. You want to communicate to people who know a little bit more about the problem than you do, right? So our expertise is in data science and machine learning. We know a lot about that, but we might not necessarily be domain experts in a specific area, but there are domain experts out there from whom we can learn a lot. So it's always very useful and valuable to start talking to these people, right? Maybe have a first look that's kind of unbiased at the data and make up your own mind, but then bring in the expertise that's out there, because it's available and people might have been looking at this problem for a great many number of years, without machine learning, but they've built up a lot of expertise here that can be useful for machine learning. All right, we have a couple of raised hands. Let's do these raised hands first. Let's take a quick pause here. Questions, please.
Martin, they have put down their hands, but we have one question in Q&A section. Do you want me to read it out for you?
Yeah, let's do it.
Okay. How can we do data validation in Python for multiple files to separate good files and bad files? Also, if you got more duplicate values in data sets, then how to handle it? That is the question from an anonymous attendee.
Well, I mean, yeah, it doesn't really depend on Python. I mean, you want to do validation, like, okay, if your data comes in different files, as in different batches, like you get a file every day or so from somebody, then, and again, that's independent of Python. You can do it in other languages as well. Like, you want to see what the baseline is, right? You want to get an impression, or you want to get an idea of what good data looks like, which you'll likely get from a larger set of historical data. So get many files, average over it, look at the distributions of your data, and then for when a new file comes in, you can compare that specific file, those specific values that you get for the different features, to what you've seen previously, and you can see whether it deviates in a significant way, which can tell you something about whether it's bad. And maybe this deviation is real, maybe something has changed in the real world and now your data is reflecting it, but maybe not. Maybe there is an issue with the data preparation and you want to talk to the people who prepare the data to help them fix it. And what was the second part of the question?
If we got more duplicate values in data sets, then how to handle it?
Right, duplicates. It depends a little bit, right, on your situation. Again, like for all these questions, there's rarely one answer that fits all. But in many cases, if they're duplicates, you want to deduplicate them. You want to remove them so that you're only dealing with distinct values. But the very fact that there are duplicates might be something that's interesting or not, again, depending on the setting. So when you do the deduplication, you might want to kind of keep track of the number of duplicates as well, because possibly this could tell you something, right, depending on your domain. All right, we have a couple more raised hands. Is that true? I only see when people raise their hands. I don't see when they put them down again.
So yeah, there is one more in the Q&A section. So guys, if you have any queries, please post it in the Q&A section so we can tackle. How to handle imbalance and give different weight to overcome bias or overfitting?
Yeah, I mean, imbalance is always tricky, right? It depends on the degree of the imbalance. So, maybe it's 60-40, in which case you want to do different things than if it's like 1 in 1,000 or something like this. Like if it's 60-40, you can kind of experiment a little bit with undersampling to see whether it works for you. Oversampling, rarely makes me happy when I try it out, but undersampling can help. And in many cases, you can push the problem to the metric that you're using, though, and you can use some weights in the metric so that the metric kind of keeps track of what you're doing. You also want to consider which metric you're using and whether the metric that you're using is relevant in the scenario, right? The obvious example would be that if you have a 90-10 imbalance and you're using accuracy as a metric, then it's very easy to get 90% accuracy, right? Where your model just predicts the majority class all of the time, but it's completely useless. So you want to kind of think a little bit about which metric is useful, whether you want to use the area under the curve, whether you want to use precision recall or F1, and that partly depends on your sort of, let's call it a business problem, right? Although, it can be a science problem as well, it can be an academic problem, but let's call it a business problem. And as to whether false positives are more of an issue in the scenario that a model will encounter, or false negatives are more of an issue. So that's something that, again, can't be answered a priori, but you want to talk to the people who will use your predictions, and you want them to help you to figure out what's the best metric here to evaluate your model on. Okay, let's move a little bit forward. We'll stop again in a couple of minutes for more questions. But I want to talk, because like these questions that have come up, they are kind of relevant for data validation and metrics, and I want to talk a little bit about that because that's the next couple of slides in my presentation anyway. So when it comes to summarizing your data through a couple of simple exploratory metrics, then there is this example called Anscombe's quartet, which is very famous in statistics circles. And I think it should be famous for data scientists and machine learners as well, because it's relevant for us too. So we have these 4 different plots of tabular data, right? Just 2 dimensions, X and Y here. And they look very different, obviously, the orange points. But if you look at their summary statistics, you'll find that all of these 4 panels, they have exactly the same mean, they have exactly the same variance, the same correlations, they have the same fit, and they have the same R squared, right? So if you don't look at them, you wouldn't be able to tell that they're different just from looking at these summary things. So, right, that comes back to this question, so the question that we had, whether data is good or bad, right? If you're doing some sort of outlier detection, for instance, that only looks at whether the mean, whether the variance falls in within a specific range, then you wouldn't be able to detect something like plot 3 down here or plot 4, because they give you the same summary statistics. So one important thing here when it comes to these kind of validations and examinations is to always plot your data, right? Always plot your data, because that will allow you to reveal outliers, skewness, missing values, data transformations, all of this, and also gorillas. So you're going to go, wait a minute, did you just say gorillas? Yeah, gorillas. So this is a gorilla, and that's from an example that was published in a genome bio paper, where students were told to analyze a data set to test the hypothesis, right? So there's something about steps and body mass index in there and the variables, and it's distinguished between male and female patients. And you can do a lot of kind of model fitting with this immediately, but unless you actually plot the data and look at it, the students wouldn't have realized that there is a gorilla that's actually literally waving out at them, right? So this is obviously something that the experimenters designed to see whether students would plot the data or whether they would just start applying models without even having seen the data in its context, right? And And this is obviously, a toy example. This is a specifically designed data set. There will rarely be any gorillas in your data, although, you can never completely rule it out. So it's always best to check. And it's always best to plot your data to get a quick impression of how different features are related, how different variables are related, whether there might be some obvious outliers, and what the shapes in your data are. And, besides gorillas, one obvious application for me is always if you just plot the distribution of your features, right? And, we're leaning a little bit on tabular data here, but, many of these distribution questions can be reframed to NLP data as well, to text data. And if you extract features in a certain way, they can also be relevant for image data, right? So you could quickly extract something like the average pixel value for your images, and then plot that as a 1D distribution. And that, should tell you whether there might be some images in your data that are significantly darker than others, right? Because they were taken at night. And if you don't account for that, then your model might learn whether an image was taken at night or during the day, rather than what the image actually shows, right? So if you get a little bit creative when it comes to extraction and feature engineering, you can reframe a lot of these things that people have learned for tabular data to other types of data as well. Anyway, so whenever you see a distribution like this in your data, and you see it quite often because that's something that you encounter for many features in real life, right? It could be the distribution of sales for a specific product. It could be the distributions of the height of mountains or hills in your country. Then the first thing that should come to your mind is, what happens if I transform this data, right? And this is very skewed. So what happens if I put on a log? And I find that this log normal transformation, this log normal distribution through this transformation can then be changed to a normal distribution, right? So in log space, this is normally distributed, and we like everything that's normally distributed because it has great statistical properties and it can be dealt with much easier, right? It's much easier to do some outlier detection and rejection on a normal distribution than it would be to do it on a log normal distribution, because where do you put the threshold for outliers here, right? This is a very long tail. Whereas here, there are some standard accepted ideas on where to put the thresholds in a normal distribution. And again, plotting your data can help you do this. And then, you can do your feature engineering, you can do your transformations to make the problem easier for you and to make it easier for your model to find out what's going on there. And always plot your data. Like I said, it's easier to do with tabular data where you can just do X, Y, and all of that. But there's also methods to do it with NLP data or with image data as well, right? So this was a post on Twitter relatively recently where somebody introduced the Know Your Data tool from the TensorFlow team, and there are other tools like this out there as well. But essentially, they would allow you to kind of query all the images that have a cat and a keyboard in them, which is a large number of images because, the internet is made for pictures of cats fundamentally, and these cats like to be near keyboards. So you get a lot of those. But, you can plot those and then you can figure out whether what is the variance in these images, what are the different poses, and depending on what you want to do with your image classification, you might get some ideas as to what sort of things you might look out for, right? Same with images with boats and fireworks. So always plot your data can be generalized to always look at your data, right? So if you have images, if you have an image data set, even if it's a huge data set, just at least look at some of the images and try to get an idea of what your typical image looks like. And like I said, you can extract some summary visuals from your images to get a better idea about that. All right, before we get to communications, let's do another round of questions.
Okay, so we have few questions, Martin.
Mhm.
Let us see. One is R or Python, which will be good. Sorry for that.
I don't know, like
Okay.
whatever works best for you, whatever works best for your problem. There is no answer as to, like, this is like this,
Yeah.
these old kung fu movies from the 70s and the 60s, right? My kung fu is better than yours. No, there's no such thing. It always depends on the individual practitioner, right? If something works best for you, then use that. And beyond that, it's always a good thing not to rely too much on one single language, right? If you're really good in Python, it still is beneficial for you to learn a little bit of R, to learn a little bit of Julia, maybe a bit of Rust, maybe a bit of C, depending, what people you work with, because one single language will very likely not be able to allow you to do everything throughout your career. So you want to have an idea what other people are doing as well. Like, I'm using both R and Python, depending on the kind of the project that I'm working on. And I found this is a good kind of setting for me. So always look kind of what's coming up, what's new, what might be interesting, and don't get boxed into this X or Y mindset, right? There's a lot of great tools out there, and like, all of them have strengths and weaknesses.
Himagiri is asking, hello, Martin. What do you suggest to a student who is in the field of BSc data science, graduation in data science, and what should he or she do to become a good data scientist?
Well, the main thing you need to do to become a good data scientist is to work with a lot of data. So do a lot of projects during your class, maybe do some projects on the side, just because you want to build up experience by getting your hands dirty with data. You want to learn on real world projects, right? And there's a lot of places where you can do that. You can do it on Kaggle, but you can do it on other places as well. You can look at GitHub for interesting data sets, interesting problems. But you want to kind of experiment with a lot of different data sets, right? Do some tabular, do some image, do some NLP, just to get an idea of how people are typically approaching these problems in real life, right? In like beyond your classes and your courses. Just take a problem and work on it a little bit. Which there's a lot of data out there, and if it's something that's kind of personally interesting for you, like sports, or something like that, or history, then find some data that's related to one of your favorite topics and do a little bit of analysis on it. Try to formulate a question, pick the right metric, right? All of these steps in the machine learning and data science process is something that you can practice with lots of data sources that are available for free on the internet. And when you do that, you build up experience, you see what other people are doing with the same data set, and you're also building a portfolio of projects, which is something that's always valuable from my point of view. So when I'm hiring, I'm looking at whether the applicants have a portfolio out there in some shape or form, right? Whether it's on Kaggle, whether it's on GitHub, whether I can see what they've done before and how they've done it, so that I can get an idea of how people approach a data problem. So doing small projects on the side can help you with a lot of things. It can help you with getting expertise. It can help you with building a portfolio for your professional goals as well.
There was one with visualization. How to visualize relationship between region, loan amount, and customers count in one graph.
That is a very specific question.
Yeah.
Are we doing homework now? No, that's fine. So region, loan amount, and what was the third thing?
Customers count.
Customers count. Well, those are three variables, right? Two variables you can plot in an XY plot. And then for a third variable, like if you have let's say 6 regions or something like this, then one thing I always like to do is to, to do the plot for each region and to do what's called a facet plot. So you have one facet for each region, X, Y, like loan amount and customer count, and you can put them next to each other in a grid of 2 by 3, and you can look at them next to each other. That would be a way to do it. But then, if you have something like region, which is a geographical feature, you could also put these facets on a map, for instance. You can kind of put the northern region here and the southern region there, and you would have this additional geo information, which might be useful, or maybe it just looks nice in a presentation. And like there are various ways, like, but whenever you have 2 features, you can easily kind of plot them in a 2-day plot. If you have 3 features, you can add an additional dimension through these facets. You can add an additional dimension through colors, for instance, or the shape of the data points that you're plotting. There's a couple of ways to do it, and we'll talk a little bit about those different plots a little further on in the presentation. All right, so let's do communication. So we talked about how to communicate with your data to find out what are the strengths and weaknesses of your data. Now it's about how to communicate with other people. So if you're thinking about how to present a certain result, then one way would be to put it in a table, right? Or, God forbid, in an Excel sheet or something like this that you send to other people. But if you want to communicate a specific finding, a specific insight, then those tables can be pretty dry. Like sometimes they work if they're just a few values and you want to highlight some, but most cases you want to go with a visualization instead, right? And of course, those 2 things, they don't exactly show the same thing, but we have kind of median temperatures here, so we can see the range of the temperatures, but we can much nicer see the range of the temperatures in this case. So this is an example from one of my notebooks in Kaggle that dealt with the temperature distributions over the year for a specific metro station, weather station in Tokyo, in Japan, right? So you see that in the summer in Japan, it gets pretty warm, right? So this is temperatures in Celsius, and it also gets pretty humid, although the humidity is kind of is less clearly shifting throughout the year, but it's still shifting. And then you have the winter months are colder. So if you want to just communicate that, then the way to go through a visualization is immediately accessible, it's immediately clear, and if you kind of put those 2 against each other, then the visualization will win. KO, no contest. And data visualization keys can also help you to build your skills of critical data consumption. So since we're living in the pandemic and it doesn't seem to be, stopping so far for various reasons, here's a pandemic example. So this thing was posted on Twitter again a little while ago, and somebody, compared to how it started and how it's going, how the year started with COVID. This is again a map. I apologize for my US centeredness, but there's a lot of resources out there that focus on the US. We take that as an example. So this was a map of COVID cases distributions in the US and at the beginning of the year, and this was a map in beginning of February when this was posted. And this person was obviously saying, well, January, look, everything was red, everything was bad and dangerous, and now this new map, it doesn't look as bad anymore because there's some blue areas in there and it's not all this kind of alarming shade of red. So things have clearly improved. But you can always rely on the data people on Twitter to, to speak up, and somebody very quickly commented, you have hereby been found guilty of committing a chart crime, right? Because obviously this is worse. But since the scale goes from 0 to 1,500 and just from 0 to 300, it's very easy to kind of to think that this is worse than this, right? But luckily they included the scales. So, everybody was able to see for themselves that, this level is actually way surpassed in February, and things have been gotten much worse, but the way it's communicated is masking that, right? So you can, I'm not going to say that it was intentional, but you can even unintentionally mislead people through data visualization. And, data viz skills will help you to see through these misleading plots and say, hey, hang on, this is actually much worse. The numbers are much higher. Why aren't we communicating that in a better way? All right. So, and there's always a lot of communication happening throughout your entire project. So if we kind of think of a machine learning or data science project like this, right? So you're sitting there, here's a project, and you're getting data from somebody, or maybe you're even extracting the data yourself, but you're getting data from somewhere, and then you're building something extremely cool and nice and valuable. And then this will feed into, it doesn't have to be a business case. It could be an academic paper. It could be another type of scientific project. But somebody somehow will use the results of your model to do something, right? And then within your model, you have these steps, right? You have EDA, you have data cleaning, you have building your model in the first place, and then iterating and optimizing it. And of course, also, this is not a one-way street either. There's a lot of kind of back and forth and iterations between, looking at the results of your model and find out you have to do more EDA or more cleaning, and then doing more cleaning after the optimization, after you find out that there's some issues there. But by and large, I think it looks like this in most cases for most of us. And at each of these steps, there is a lot of value that you can get out of by communicating, right? So you can talk to the people that give you your data, if they are those people. And maybe they can help you with the data cleaning. Maybe there's something going wrong on their end. Maybe they can help you with EDA by understanding better what those features mean, right? And then on the other end of your project, you want to talk to the people that will use your data, right? Maybe the type of model that you choose will be impacted by the type of business case or academic case that your model will be employed under. And maybe the optimization will be impacted as well, because the question is what to optimize for, right? We talked about this earlier. Want to optimize for precision, or do you want to optimize for recall, for instance, right? So there's a lot of communication happening here at each of these stages, and it's very important to do this. It's very important to talk to people, and when you're talking to people, you can use those skills of data visualization and data communication that you learned by communicating with the data to communicate the data to other people, right? So let's wrap up this first part, main part really, with these 4 principles, right? Garbage in, garbage out. If your data isn't great, then your model is not going to be great either. Be aware of bias, and bias is related to how your model will be used and what you're actually aiming for. Always plot your data, or always look at your data, at least in some shape or form. Don't just immediately throw it into your favorite deep learning tool, but look at the data to see what could go wrong. And communication is key, right? You want to figure out how to communicate your insights. You want to figure out how to communicate your process in a kind of accessible and clear and reproducible way, so that you can also communicate it to yourself like 1 year in the future or so, and reduce this danger of tech debt, of just having a very cool and a very high performing model, but nobody can figure out how it works because it's not well documented and not well communicated. And that's always a shame if you encounter something like this, because you can put it in a little bit more effort at the stage where you're building it and documenting it, and it will be much more usable and accessible for people. All right, let's take another few questions, and then we'll just go through some examples. If there are questions, if there are no questions.
Yeah, there are a lot actually. So yeah, let us see. How can we plot data distribution in Python?
Seaborn.
There is
Use
a
the Seaborn
question.
package. It's best. It's better than others.
One from Mukul Sharma. Are there any specific libraries you recommend to enhance the Jupyter notebook? Something with plotting and data description apart from basic matplotlib and Seaborn.
Well, like I said, when I use Python for data visualization, I use Seaborn. I like it better than the kind of interactive tools like Plotly, for instance, but you can try those out as well. But I don't often do it because I prefer to use R for data exploration and data visualization. And R has ggplot2, which is a very powerful package with a lot of kind of add-ons, with a lot of kind of packages that work very well with it. So that's my go-to approach.
Okay. Then there are a few more. One from Tirthankar Datta. Hi, Martin. Small question. Where will you be starting with tuning Jupyter notebooks for good to great presentations? Sorry for being a little impatient.
We'll talk about this in the next couple slides. Yeah. Okay, hang on for a moment.
Exactly. Talking about doing real life projects, what are best practices for deploying models, and is it necessary to be able to write home codes?
To be able to write what?
Home codes. Home codes. I don't know what that means.
I don't know that either. I'm sorry. I mean, so like, you want to think about how often your model needs to be retrained, right? In a kind of production setting, whether it needs to be retrained. In most cases, it probably will. Like if you're dealing with some business problem, then you know, there's been a lot of changes in the business world recently and over the last years. So you know, everything that happened during COVID had a likely chance to completely disrupt your training data if you think about the way that people interacted and their habits changed during that time. So you want to make sure that it's easy for you to kind of to retrain and update your model, and you want to have some monitoring going on as to whether the results that your model gives will degrade over time. So you have to think about how you model the performance, you monitor the performance of your model during production. I think this is the most important aspect, because if you don't know what's going wrong with your model, then you can't even decide whether to retrain it or not. Okay, so let's talk a little bit about so the question came up, where to start with notebooks, and this is actually the part that I want to talk about next. My guidelines for notebooks and exploration. And for this, I'm using, if you're interested, I'm using two of my notebooks on Kaggle. One is on the taxi trip competition. The other one is on a sales forecasting competition. And even though the kind of the data sets are different, I mean, they're both tabular, but otherwise they're pretty different. We can follow roughly similar guidelines. So the first one would be to start out by understanding your data context, right? Where does your data come from? What are the features? What do they mean? And on Kaggle, it's relatively nice because the data is cleaned up and prepared for you, and there's always a description that tells you what the context is. And just read everything that's related to the data. And in a business context, like I said, talk to the people that give you your data to lower the chance that there's some misunderstanding going on, because you don't want this. You don't want to build something that's great, but that doesn't really address the problem that you've been asked to address, right? So understand the context and understand what your features mean. And if you don't know what your features mean, then you can go back again and talk to the people who prepared your data and ask them for that. Second one is, we talked about this, look at your data, right? Start out just looking at the tables if they're tables, at the texts if they're text, look at some sample images if they're images, and get a kind of quick feel of what's going on with the data. Like what does it look like? How is it structured? And then always plot your data, right? So you can start with some simple line plots for sales. It's always good. Some kind of bar plots are good whenever you have categories, right? Those are the two fundamental tools that I would use for continuous and for categorical features. And then you can get gradually more complex, right? So we talked about these facets. So if you think back of your, was it regions and customer counts and loan amounts, right? So those are regions in the US or, states in the US. And they the sales performance here is different between California and Texas and Wisconsin. So you can use those facets to put them kind of next to each other to kind of immediately see, okay, this is a much smaller range. This is a very wide range, but there are still these yearly cycles here that are relevant. And oh my God, what's happening in Wisconsin, right? There was nothing here at the beginning and then it suddenly jumps up. So this is a way how you can put them next to each other. So always plot your data and, like I said, gradually build up complexity. So these facets, they can work in one dimension, right? So here we have a categorical variable with 3 values, California, Texas, and Wisconsin. And you can just arrange the facets along this value. But you can use kind of 2-dimensional facets to increase that to a grid, right? So you still have California and Texas and Wisconsin here on the y-axis, and then you have the different sales departments here on the x-axis, in a sense, on the x-axis of the grid. So you have 3 categories here, 7 categories here, and you can build a grid, and you can kind of take each of them apart and look at each of them separately and simultaneously. So you can increase the dimensionality of your 2D plot by 2 additional categorical dimensions by using these facet grids. And of course, there are limitations here, like if you have thousands of categorical values, then it's not going to work, but you can still look at the 5 most frequently. So, right, in a similar way, you can use these heat maps in order to kind of combine some features that can be, they can be categorical, they can be ordinal. Hour of the day is an integer feature essentially, but it doesn't take that many values, so that makes it easier. But heat maps are a great way to figure out, are there some like patterns in your data? Are there some things that kind of come out? So you build up this complexity, you bring in more feature relations, and it will tell you more about your data, right? And then you can start, once you have these basics down, you can start looking at things from different angles, right? Instead of using a line plot for a time series, you can plot things on a calendar, because then you'll see that, okay, this range of dates is special for California, but Texas uses a different format, right? The orange days, it doesn't really matter what they are here, but the orange days are not all in a row, but they are distributed like this. So there's a difference happening here. You can use a 9 plot, I suppose, in order to visualize that, but it's much nicer in this calendar view because it immediately becomes obvious of what's going on. And for this one, there was a continuous target that we were supposed to predict whether how fast something was going. And the kind of shift in angle here was to look at it from a categorical point of view, just kind of bin it into slow and fast, which is not something you want to do for your model because, you take away the resolution. But in order to visualize something, it can help to look at the regression problem from a classification point of view, or maybe you can look at a classification problem from a regression point of view, And this kind of shift in angles, this kind of shift in perspective can sometimes tell you something new about your data. And like I said, you're writing for an audience, perhaps, but you're always writing for yourself. You're always writing down to document your findings, to document your ideas, so that you don't just have a kind of a large sequence of plots where you show all of the cool things, but then when you get back to it 3 months later, you have forgotten what most of the cool things are. But if you write it down, if you immediately write down, okay, in this plot we see this and this and this, and that's important because of that reason, then it's the same way as documenting your code, right? So that your code is kind of accessible and readable. And the same way you should document your analysis with the insights that you find. And if you want to get kind of inspiration of what nice notebooks look at, I have this series on Kaggle. It's called Hidden Gems, where I look for notebooks that are, that are great in one aspect or another, right? Great data visualization, great storytelling or something like this, but they haven't gotten much feedback, much engagement for the community, and I'll post them so that other people can see it too. And we actually just had a competition on this. It finished a couple of days ago, but for this competition, I invited people to write notebooks on this set of hidden gems. And the way that those notebooks were evaluated followed those criteria, right? And those criteria summarize what I think of a great notebook should be, right? What are the main aspects of a great notebook, right? The data visuals, the narrative aspect, structure and presentation, right? Because you can make a notebook very confusing, but you can also make it very clear as to what are the different parts of it and what are they aiming for. And of course, quality of insights, right? There should be something important in there. And for this particular competition, I was also looking at creativity and originality. It's not always needed, right? Not for every business problem or paper, you need to come up with a completely new way of communicating something. But it, like if you come up with something that's kind of different, it helps to get the attention of your audience and get them interested in it. So this is something that shouldn't be neglected completely. All right, let's do some questions. And this is essentially the end of my presentation. Like I have a bunch of more examples that we can look at, but let's do some questions and deal with the questions because they're more important. And then if we have some time in the end, we can look at some of the examples.
Yeah, sure. Let me see a few questions for you. Okay, can you please summarize EDA guidelines once again? It was from IB Karthikeyan.
Oh, well, you can watch the recording of this.
Yeah.
I also, I have it somewhere in a blog of mine. I have a blog. If you go to Kaggle, you'll find my blog in a link there. But I can do it for you. Understand the context of your data. Look at your data. Always plot your data. And in these plots, gradually build up complexity to study feature relations. Investigate your data from different angles to kind of do some out-of-the-box thinking and give you different ideas. And always document your thoughts and ideas and everything you find in your analysis.
Okay, so we have one interesting question from Achal. Okay, how does one measure the success of data science project in a typical real world business setting?
This is a very broad question. It depends on what you define, what you mean by success, what you mean by data project, and what you mean by business setting. I mean, like if it is a machine learning model that you're putting into production, then the success is easier to measure, right? Because you're evaluating the performance of your model on a certain metric. Again, it can be accuracy, it can be RMS, it can be precision or recall or something like this. So you have a real measure there, and then you can kind of keep measuring how it's performing in production, and model it monitor it in production. Is when it comes to data projects, I don't know, data project can be a lot of stuff. Like if you're building a dashboard, for instance, that you want people to look at, then you want to include some ways to measure the engagement of people with this dashboard, right? You want to figure out whether people actually look at this dashboard and whether it's useful for them or not, right? Whether they kind of look at it once and then they decide, okay, that's not useful for me, and then just ignore it. So you kind of want to measure engagement there in some way. If you're writing a paper, you like to know whether people read the paper, whether people, cite it, whether they engage with it. So there's this is kind of a very broad question from many perspectives, but communication helps you to figure out the answer to that in your specific setting, right? Like if you're just starting out and your task is to write kind of write an EDA on something, right? And then you finish with it and you're very happy and you give it to people, then ask them, do they have any questions? What are they doing with this information? Do they just take it and put it in a drawer and ignore it? In which case, that wasn't great, and maybe they really wanted something else. So it's very kind of complex scenarios in which we're in. And I'm not sure whether I answered your question, but those are the thoughts that I have about it.
It's certainly helpful. Okay. One is from Ogobushi. I want to train a model with CNN. Seeing that CNN works better with image data, how can I convert the numerical data into images to feed into CNN?
Whoa, okay, there's a lot here. Like CNN, yeah, you use convolutional networks on images. You would have to have a very good reason to transform your data from a different format into an image and then do some analysis on there. So you want to, like, if your only reason is that you want to try out a different kind of model, then this might not be the best way to do it. But one thing that people are doing, for instance, they're using image models for audio data, right? You can transform audio data into a 2D spectrogram where you have time and frequency. And then people get a lot of good results by using those image models on a transformed audio data. So that's something that has been working. But like CNNs are built for images and images only. Like if you don't have a good reason to transform your problem into an image, then maybe do something else instead of trying to fit this square peg into the CNN round hole.
One from Satish. What is your thought on using Amazon's SegMaker for building ML models compared to building models manually?
That's a very straightforward answer. I don't know. I haven't used SageMaker.
So yeah, Martin, there are a lot of questions, but more or less similar on the things we have discussed so far. Like the questions you have already answered, they are in that similar zone. So,
okay.
I'm not able to find any new.
Well, then maybe we can kind of conclude with my suggestion to get inspiration from Kaggle Hidden Gems specifically and from Kaggle in general, right? There's a lot of inspiration there when it comes to, how to write great narration and storytelling, how to craft engaging visuals that tell a story as well and communicate specific insights. Like there are some plots in some of these notebooks that would not look out of place in a science or nature paper. Introduce your work, write an introduction, put some images in there to make it interesting, right? This kind of almost goes in the direction of data journalism, right? How to make your results accessible. You can even communicate your methodology through kind of pictograms like this. This was a very interesting approach that I saw in one of those notebooks. You can, add some structure, add some kind of, this is one of the more basic elements that you structure your kind of chapters and sections in your notebook. Like R allows you to do that with these tabs, right? You can click on this and you can get a new part. You can click on that, you can get a different part. And sometimes it helps you a lot by understanding your model. So there's this great kernel that I really want everybody to check out. It's called The Journey of an Image Through a Neural Network. And it kind of touches on the CNN question that we had, but here it's the other way around. So this person wrote a kernel that kind of looks at what the different layers are seeing in the neural network, and then, brought in some dimensionality reduction and clustering to see, what's happened in the convolution stage and in the flattened stage, and then what the output looks like. And this is MNIST, obviously, so handwritten digits. So, you can find all sorts of great inspiration on Kaggle when it comes to how to write engaging and interesting notebooks, and how other people are doing it, how other people are approaching it.
One request I'm getting from many, Martin, will you be able to share this PPT with them?
I'm sorry, will I be able to share what?
The presentation, PowerPoint presentation with them.
I can think about it, but then again, you can find it in the recording.
Yeah.
And you can kind of watch it in the recording.
Yeah, sure. Okay. Fine. So I guess that's it. And we have concluded most of the questions, and others are in that similar zone. Fine. So thanks a lot, Martin. On behalf of Analytics Vidhya, I would like to thank you for your time and delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. Thank you so much.
It was a great pleasure. Thank you very much for having me. If any on the audience has more questions for me, just hit me up on Twitter, tweet at me, ask me anything. You can find me on Kaggle and on Twitter. That's where I mostly hang out. I'm on LinkedIn as well. If you want to connect with me there, feel free. And feel free to ask any more questions that you might have. And thank you again so much for having me.
Yeah,
have a good evening.
Sure. Yeah, thank you.